All right, this is the first lesson in Unit 5, which is solving systems of equations and inequalities by graphing. A system of equations is a collection of two or more equations with the same variables. So this is new. Solutions of systems of equations are the variable values that make every equation true. So before, if we had 2x plus y equals 8, and I said, is the point 3, 2 a solution? You would have to plug it in and make it true. So 2 times 3 plus 2 equals 8. 2 times 3 is 6 plus 2 is 8. So yes, so this would be a solution. In what we're doing today, we have two equations. It's a system, and so if you wanted to know if 3, 2 was a solution, you would have to plug it into both equations, and it would have to be true in both of them to be a solution. Okay? All right, there's three possible things that can happen, so let's go ahead and graph. So this one, the y-intercept is negative 5, 1, 2, 3, 4, 5, negative 5, and you're going to go up 2 over 1. And you just need to take notes on notebook paper. You don't need to write every little thing down, but you need to write down the important information. So 2x minus 5, and then I'm going to graph negative x plus 6. So that one has a y-intercept at 6. And then you go down 1 over 1. And where they intersect, so these intersect one time. Where they intersect is the solution. So this one has one solution. So I would just draw two intersecting lines and write one solution beside of that. Over here, I have a y-intercept of 5, 1, 2, 3, 4, 5, and my slope is 2 over 3, so I go up 2 over 3. Then I have a y-intercept of negative 3, and you go up 2 over 3. All right, what kind of lines do I have here? I have parallel lines because they had the same slope, and these have no solution because they never intersect. So you should draw two parallel lines and write no solution because they never intersect. All right, and then here's another one. Y equals 1/3 x minus 1. The y-intercept is negative 1, and then you go up 1 over 3. Now what do I have to do before I can graph this one? I have to solve for y. Very good. So I have to divide by 3. So this one, you get y equals 1/3 x minus 1. Well, if you notice, that's the same equation. So if you go to negative 1, up 1 over 3, it's going to be the same line. So these touch at every single point on the line. They're the same line, so they touch at every point. That is called infinitely many solutions. So if it's the same line, then you're going to get infinitely many solutions. So make sure to write that down. Remember, you can pause this at any time to write things down. All right, here's an example. What is the solution to the system of linear equations that is graphed below? Well, the solution is going to be where they intersect. I know you can't see this, but these intersect at 2, 2. So that would be your answer. The solution would be 2, 2, where they intersect. All right, here's another one. Where's the solution to this one? The solution is where they intersect. So 3, 2. Remember, your x value comes first and then your y value. So that's your answer. All right, the graph for two linear equations is shown on the coordinate plane. Together, these equations make a system. Select the coordinate point that solves this system. So you have a point A, a point B, a point C, a point D, and a point E. Which one is the one that solves the system? Well, it's right here. So your answer is point D. How many solutions are there to the linear system shown in the graphs below? Well, what kind of lines do we have? Parallel. How many times do they intersect? None. So the answer is no solution. Okay? All right, number 5. Solve the following system of equations by graphing. Okay, well, if it was calculator inactive, you would have to draw your line and solve for y on both of them. If it's calculator active, you could put both equations into Desmos. Okay, So let's put both equations into Desmos. Let's assume that it is calculator active. So I'm going to Desmos. All right, so negative 4x plus 3y equals negative 12. And then negative 2x plus 3y equals negative 18. All right, so I've typed them both into Desmos, and I need to find where they intersect. So I've got to move the computer, and then you click on the intersection, and Desmos says negative 3, negative 8. If I go back and look at my answer choices, the correct answer would then be B. Okay. All right, calculator inactive. How many solutions does the linear system have? So this is one that I would need to use graph paper. And remember, you'll have graph paper on every test. So if I wanted to graph x equals 3, I would go over 3 and draw a straight line. And then if I wanted to graph y equals negative 2, I would go down 2 and draw a straight line. Well, how many times did the two lines that I drew intersect? They intersect one time, exactly 1 point. Okay. Calculator active, what is the point of intersection for the lines y minus x equals 0 and 3x plus 5y equals 15? All right, well, this one's calculator active, so the best and easiest thing to do, Desmos. So y minus x equals 0 and 3x plus 5y equals 15. All right, I've typed them into Desmos. I'm going to hit the house over here, and these intersect at 1.875, 1.875. So that is answer choice B again. All right, number 8. Raina paid $200 fee to join a health club and then a $50 fee per month to use the club. The total amount of money T paid can be represented by the equation where M represents the number of months of club use. Nora paid a $100 fee to join another health club and then a $75 fee per month to use the club, which can be represented by the equation. All right, so this one would be y equals 100 plus 75m. The graph below shows the fees paid by Raina and Nora. So they've already graphed it. In what month will both girls have paid an equal amount of money to their health clubs? All right, equal is where they are going to be the same, and they're going to be the same where they intersect. At this point, they are both at 400. That's the only place where they are equal, 4 and 400. So this is month 4. So that's answer C. Calculator active. Which order pair is the solution set of the system of equations y equals negative x plus 1 and y equals x squared plus 5x plus 6? Select all. Select all means there's going to be more than one answer. Okay, so let me type this one in. Y equals negative x plus 1. And then the other one was x squared plus 5x plus 6. All right, notice this one is a quadratic, which we'll learn more about later, and linear, so it intersects at 2 points, negative 5, 6, and negative 1, 2. So two answers, negative 5, 6, and negative 1, 2. Okay, and then this one, calculator active, what is the positive solution to y equals 2x plus 4 and y equals 2 times 3 to the x power. Okay, so I've put them both in. They intersect here and they intersect here, but remember this one asks for the positive solution. So the positive solution would be 1, 6. Okay. All right, number 11, calculator inactive. A system of inequalities is shown below. Which point is a viable solution to the system? All right, the first thing I want to do is show you how to graph these. So even if you don't have graph paper on your notebook paper, go ahead and draw a y-axis and an x-axis. Alright, so on your notebook paper, go ahead and draw an x and y axis. If you have graph paper, that'd be great. Alright, so this one's calculator inactive, so I'm going to graph it. To graph this one, I go to +5. Remember, you can pause the video. And then you go down 2 over 1. Now remember, this one's going to be dotted because it's not equal to. So this one's going to be dotted. And greater than means shade above. Okay. All right, so we're doing a system, which means there's going to be two things. So we're also going to graph this line. So y is less than or equal to -3. So you go to -3. This one's going to be a straight across solid line. And this one is less than, so you shade below. All right, in inequalities, you don't just have one point as your answer. You have a solution region. So here is the solution region. Any point in here is a solution. Any point in here. So if I look at A, 1, -2, so if I go to 1 and then -2, is it in the highlighted region? No. All right, then I can go to 4, -3, and it is not in the, sorry, I just did this wrong because this is y is less than or equal to -3, and I went to +3. All right, let me start over real quick. So x and y. All right. So we were doing -2x + 5, 1, 2, 3, 4, 5. Then I go down 2 over 1, and this one is dotted. And then I shade above. Okay, now I'm going to do y is less than or equal to -3. So I'm going to go to -3 and draw a line straight across. And this one gets shaded below. All right, so this one has a very small place where the shading overlaps, okay? All right, so let me check my points again. A was 1, -2, nope, still doesn't work. B was 4, -3, no, still doesn't work. C was 6, 2, nope. D, 8, -4, 1, 2, 3, 4, 5, 6, 7, 8, -4. Yes, that's going to end up in the highlighted region. So your answer is D. Okay. You could also plug the points in. So for instance, if you plug in -2 greater than -2 times 1 plus 5, you have to plug it into this one and you have to plug it into that one, and it has to make them both true. All right, and A, B, and C do not. If you plugged in D into both of them, it would make them both true. Okay. All right, let's do number 12. It is calculator active. So that means we can use Desmos, which is great. All right, so I am typing in y is less than 2x plus 1. and y is greater than 2x minus 3. All right, you'll see that Desmos is fabulous as always because it shades it for you, it makes them dotted. So the solutions are where they overlap, which is in here. Okay, so these are not solutions, these are not solutions. Everything in here is a solution. All right, this question says, which point is not a solution? All right, so 0, 0, 0, 0 is in the solution. And remember with Desmos, you can always come over here and type in your point. All right, and it'll graph it for you. So that's in there. All right, B was the point -1, -1. All right, that one is on the dotted line. You're not allowed to have a point on a dotted line because dotted lines are not equal, not included values. All right, C, all right, so this one is not a solution, -1, 1, and then D, -4, -4. All right, so which point were not solutions? So there actually were 3 of them that were not solutions. So I think I have a typo. This question should say which point is a solution. All right, so 0, 0 was the only one. Okay. All right, 13, write a system of equalities for the graph. So here's your solution region. They're only showing you the part where it overlapped. And notice that even though you can't see the lines, it's shaded below whatever lines you have. So if you look at A, those are greater thans, which are shaded above. B has a less than and a greater than. We want both of them to be less than. So that would be answer C. They're both less than or equal to. Okay. 14, a system of inequalities shown below. Which graph shows the solution set to the system? Let's say this one is calculator inactive. So you would need to solve for y. So this one has a y-intercept of 3, goes down 2/1, and you shade above, because it's greater than, you shade above. So it can't be B, because that one they shaded below. All right, remember with this one, when you solve it, you subtract 1x, and then you have to divide by -1. And when you divide by negative, it flips your sign. It flips your sign. So this one is also going to be shade above. So that both of them are shade above. So that makes it A. That's where they've shaded both of them above. All right, last two. Trevor's making 2 types of bracelets. Each type P bracelet needs 12 inches of leather and 3 inches of string. Each type Q bracelet needs 4 inches of leather and 18 inches of string. Trevor has 5 yards of leather and 6 yards of string. X equals the number of types of P bracelet Trevor makes. Y equals the number of types of Q bracelets Trevor makes. Which system of equation models the constraints on the number of bracelets Trevor can make? Okay. All right, so notice that you have 12 inches, 3 inches, 4 inches, 18 inches, and then you have 5 yards. You can't have inches and yards in the same problem without doing some conversions. So in a yard, there are 36 inches equals 1 yard. So we need to multiply 5 by 36. That gives me 180. So that's where they're getting the 180 from. So you can mark out C and D because they kept it in yards, and you got to convert it to inches. Okay. All right, it says X equals the type of P bracelets. So for P bracelets, he needs 12 and 3. So we need the one that has 12 and 3 in it, which is B. All right. All right, Jason wants to earn at least $250 each week working during the summer. He earns $6 an hour babysitting, $7.75 an hour working at a store. He can work no more than 40 hours each week. okay? All right, so you've got money, money, money. So you got 6 and 775 in your first equation. Well, if this is money and this is money, then this also needs to be money. So C and D don't have money, so 250 should go here. He wants at least 250, so that's greater than or equal to 250. So the answer is A.